So, hello. Thanks for attending the MUM and welcome to another user meeting in Prague. It's been a while since we've been here. I think it was 2009, the last time here. My name's Patrik Schaub. I'm going to talk about public Wi-Fi today. And before we start with the topic, I want to tell you a few words about our company. Well, I think I'll try to switch the microphone. Just hang on a second. Okay, yes, here we go. Okay, I'm Patrik Schaub from FMS Internet Service in Germany. We are a value-added distributor. We've been on the market for 17 years now, so we bring quite a bit of networking experience with us. And in terms of distribution, MikroTik is one of our core products. So MikroTik and MikroTik accessories are things that we're dealing with every day. And we're also rather big in professional wireless point-to-point links like microwaves or V and E-band solutions. And we're a general supplier for alternative ISPs or alternative carriers. If you're interested in our products, you're welcome to have a look at our online shop, and you'll see most there. Next to distribution, we are offering a few services. First of all, quite a lot of training. We are a MikroTik training partner since 2007 and have been the first training partner in the German-speaking countries. So we're doing that for quite a while, and my colleague Sebastian is doing about half of his time MikroTik trainings. He's qualified to do all the engineer level certifications, but we're also working for some other vendors by now and doing certification for their equipment. Next to training, we're offering consultancy services, sometimes to enterprise customers, but usually also to ISPs and alternative carriers. We have an upcoming training of CAPSMAN. It's actually the first CAPSMAN training we're doing. It'll take place in Austria at the premises of our partner ASMAN24. And since this is relating to my topic today, I want to make you aware of that. So if you're interested, it's in German language, obviously. You're welcome to participate. You're also welcome to drop by at our distributor table here in the exhibition area. We brought access nodes from Alcatel-Lucent, whom we are a distributor for. So if you're interested in DSL or GPON or active Ethernet, that might be something for you. And we brought quite a bit of equipment from SAF Technica, which is our preferred vendor for microwave installations. So if you want to see their measurement tools, their spectrum analyzers, their signal generators, or their microwaves, you're also welcome to pay us a visit. Next to that, we've got V-band equipment from Sub-10 short-haul gigabit links, also available at our exhibition table. Next to that, we've got two products with us that are relating to the presentation today. That is a site survey software and a custom-made access point based on MikroTik or with MikroTik inside. Actually, MikroTik will give you almost all you need in terms of software and hardware to build professional Wi-Fi services. But site survey software is not yet something they came up with. And site survey software is pretty handy in the planning phase when you want to simulate your network, like read in CAD files, place virtual access points, and get an idea what the coverage will be like. But also after you deployed your installations, when you want to do passive or active surveys, that is, draw a weather map of the signals on the different floors, or get an idea what the real throughput, the real bandwidth in different areas is. Our solution also supports GPS and automatic map download, so if you're doing surveys for outdoor areas, that's pretty handy too, since all you need is to plug in your GPS receiver and you will get the maps for the area you're walking through automatically. The second product on the right-hand side is a custom-made access point with a MikroTik mainboard and MikroTik Wi-Fi interface. But what we found, especially for professional installations, is that customers today are demanding dual-band devices today finally we got a dual band device introduced, an upcoming one, but so far there was no possibility to have complete dual band systems, especially not with AC standard. So that's something we are providing. If you're interested in OEM-based access points, come by. It's also possible to have your own logo or your own color for these devices. Public Wi-Fi altogether is more or less a boring topic. If you look at that, it's been around for a long time and the concepts did not really change. But in distribution we saw that the turnover for public Wi-Fi projects is starting to raise again since about 1.5 years. And we tried to find out what the reasons for this are. Actually, we think there are like 3 stages in the public Wi-Fi history. During the first stage, like 10 years ago, some people thought it might be a nice marketing idea to offer Wi-Fi in their hotel or conference room, but they never thought it's a really important service, so they didn't really care on the coverage or anything else. That did definitely change at latest 5 years ago when these companies found out that Wi-Fi or Wi-Fi services will help them to earn more money, to get more customers, and they started to care for the quality. They wanted to have good coverage and they started to care about legal issues they might run into, so they wanted to have access control. And the first, today we call it cloud-based Wi-Fi services, started to pop up and offer complete solutions for hotels, hospitals, and all the other potential customers. But today the situation again has changed. Wi-Fi will not help you to make extra money anymore. It's the other way around. If you're not offering Wi-Fi in certain businesses, you will definitely start to lose money. You're not going to get bookings, you're not going to get big conferences. And losing money is even worse than not earning extra money. So today the customers are really looking at what they're going to deploy if they're having a new Wi-Fi installation. And they also start to push their old installations, that is, they're starting to redo things, and they're looking for a high throughput. They want to have dual band coverage across their complete premises. That means you need to have more access points, since 5 GHz coverage will be more of a hassle in an indoor environment. More access points will lead to more administration overhead. So it's getting more complicated. And the customers are also starting to look at multiple services. It's not only about surfing the internet and email anymore, but people want to do video streaming, they want to do voice over IP. All the services that they're used from their homes should be working in the hotel or conference destination too. Another thing that customers are starting to come up with is dual use of their Wi-Fi infrastructure. That is, they don't want to deploy a second Wi-Fi for internal usage, but when they're investing money in good coverage, they want to make sure they can use this Wi-Fi also for their stuff, maybe their machine-to-machine communication in some companies. So this is something that's adding up to the requirements of a modern Wi-Fi network. And just to complete this, one of the recent changes definitely is also, at least in Germany, that these Wi-Fis are offered as a free service. So payment gateways, for example, are getting less important. So like the summary of the latest requirements is that Wi-Fi has to be easy to use with all devices. It must be easy to operate and without any legal risks for the company who is running it. It should be very reliable and bring you high throughputs. Dual use for public and internal networking should be possible. And many customers require a tight integration into their back-end processes and customization in their corporate design. So luckily, MikroTik brings us almost all we need to build all sorts of Wi-Fi services. And before we start to look at real Wi-Fi services and like build some of them together, I want to introduce the basic components that are being used. First of all, we have hotspot. Probably most of you know what a hotspot is. It's MikroTik's implementation of a captive portal. That is, it's that piece of software that will allow you to do HTTP authentication for your clients. That is, enter your user credentials on a web page instead of using an encryption or some other technology. How it's working is pretty easy. A firewall will block all traffic from the internal to the external network until it sees the first HTTP packets to arrive, and these packets will be forwarded to an internal login page and present the user with username and password fields instead of the website that he actually wanted to open. And once this has been verified, the firewall is opening for all subsequent traffic of the same user. A hotspot or captive portal is definitely the core concept of all public Wi-Fi services, and of course there are quite a few more vendors than MikroTik. But MikroTik's implementation is free for you, it's free of charge. It's an additional package for Router OS, so all you have to do is to configure it. Maybe you should take a look at the license level you're using, that everything fits, but basically there's no extra payment. Although the hotspot feature will give you quite a lot of flexibility. Multiple user authentication means a local user database as well as a radius database that you can use. Powerful accounting settings, walled garden to give you access to websites without authentication. So check out the whole list in the wiki if you're interested in that. And the second big topic, or the second big package that MikroTik is offering you, is User Manager. It's a, let's say, radius implementation with a web interface that will let you easily manage the user database. It's working together with Hotspot. That is, your hotspot can be configured to ask User Manager for the accounts, verify them, and then open the firewall and let the customer go to the internet. For User Manager, it's the same. It's a free package. You will have to install it separately. It's not in the core installation, so you have to download it, get it. You can run it on your box. Maybe you don't want to use an RB750 or something very small, but in general, it would already do the job. It's an alternative to complex radius installations, and it brings you an easy-to-use graphical interface. So you might even be able to pass the login to User Manager to your customers, since the User Manager login will not allow them to configure their router. User Manager also supports multiple NAS and multiple services, so you can not only use it for hotspot, you can do single logon for VPN, for example, at the same time. And it has some ticket creation features. It supports templates for tickets. You can do bulk ticket printing, like printing 200 tickets and pass it to the reception. And it also has payment gateways, which are, at least in our customer base, not used very often. More interesting might be the session log that will give you a long-term log on what your users really did. The third feature, and that's maybe more interesting since it's a bit newer, it's CapsMan. It's MikroTik's implementation of a Wi-Fi controller. And MikroTik's Wi-Fi controller does basically two things. It'll deploy configuration to your access points. It can optionally also handle traffic of the access points. That's what you see here. All access point traffic can be pushed to the CapsMan. But it will also allow you a local forwarding mode that is pushing traffic to the local network. CapsMan also is a free Router OS package. I think that's pretty good to know, since quite a few companies are earning money by selling their controller-based software. And it's also very good that it runs on Router OS, so you will not need dedicated hardware at your customer side if you're having a small installation with a local Caps Manager. As I said, it will do the central configuration and provisioning of the access points. It will allow you to do central Router OS updates if you want to do so. It will allow management of user traffic, and you can use it in layer 2 or layer 3 deployments. We'll have examples on that later on. So next to the three big packages, Hotspot, User Manager, CapsMan, Router OS comes with a lot of standard features that will make it very easy to build professional Wi-Fi services, as in such services you will usually have to adapt to special network situations or special customer needs. And all of you know MikroTik gives us a lot of capabilities. I just want to name a few that come in very handy with these installations. Wi-Fi based features are the virtual access points, for example, or the connect list that will let you kick out users if their signal is not sufficient, for example. But also access-based technologies like a wireless distribution set or meshing that might be handy if you have to use a wireless backbone for your access points. Wireless backbone usually is one of the headaches that customers will run in, so we do not really suggest to use it. We would prefer a cable-based installation, but still MikroTik gives you all the means you need to react in special situations. And there are also quite a few very common features that you need to build a professional service. VLANs, rapid spanning tree that can also work together with WDS, load balancing if you have multiple broadband lines to balance your traffic on, 3G, 4G as alternative uplinks if you don't have broadband lines available, VPN to tunnel your infrastructure to a central data center, or scripting in NetFlow. So when you look at professional Wi-Fi services, companies who are really deploying Wi-Fi for a lot of sites, there are three basic concepts. We have local setups. In a local setup, you will have your hotspot, your user manager, and your access points all on site. And this is something that is typically used by customers directly. That is, it's not a typical setup for Wi-Fi service providers. It's very easy, it doesn't need any external services, traffic will be forwarded locally, and you have no tunneling overhead. The second general possibility is to use remote user management. That is, you will still have all your equipment at your customer site. You're only using, moving the user manager to a data center or any other radio system to a data center. And this is still a pretty simple setup, as you will not have tunneling. You will still forward all your traffic locally, but you have a central user management which you can, for example, use to give single log-on to multiple hotels belonging to one chain. And this is a type of setup which is quite common, even for bigger professional Wi-Fi operators. And positioning in the data center also allows better hosting capabilities for big user management systems, as they might need bigger platforms and come with the typical requirements. Here is just an example for two sites being connected to the same user manager. Of course, you can connect a third and fourth and fifth one. So this, the remote setup, is probably what most, at least in our customer base, most professional Wi-Fi service operators run. Today you would probably call it a cloud service, as actually everything is happening in the data center. On the customer side, you're only building a tunnel, a layer 2 tunnel into the data center, and even the traffic is being forwarded to the data center. So the local broadband connection is only needed for traffic forwarding. In our example here, I'm still referring to Ethernet over IP as a tunnel technology. That's actually not necessary today anymore. In the older days, Ethernet over IP has been the only mean to get a transparent layer 2 tunnel. Today you could simply bridge VPN interfaces. But since we still have so many installations around, I wanted to show the complete picture. So in a remote setup, traffic will not be forwarded locally. It'll go to the data center and it will leave from the data center. So from an external point of view, user traffic is starting at the data center, and this is going to shift the complete responsibility, the legal responsibility, from the owner of the broadband connection to the company that is operating the data center or the service in the data center. Of course, you can also cover multiple sites on this setup, and based on this remote setup, I want to show you two implementations, one using CapsMan and one without CapsMan, on how an actual service could look like. So this is an example, or let's say the first step of a complete remotely managed public Wi-Fi service. What you see is the access points here on site, the tunnel router, everything here is bridged together. So all the traffic is being forwarded to the tunnel router and through the EOIP tunnel to the hotspot in the data center. Hotspot is going to pass DHCP leases to the local access points. Of course, you'll need, or you might need PPPoE to connect to your DSL line and maybe a VPN connection to run your EOIP tunnel through. This gives you some overhead, but this is still a setup which is in place at a lot of installations, also big installations, so it's worth to take a look at. And here on that slide you see all the infrastructure that you need for the transparent layer 2 connection. After your connection is up and running and your clients are getting DHCP from the data center, you want to configure user manager, which is also placed in the data center. What you have to do is you go to your hotspot profile and tell it to use radios for authentication. So hotspot is not only looking at the local user database, but also asking the radio server for that given user. But you do also have to set up the radios connection to that radio server. So in the main menu you choose radios on the hotspot, enable it, give it an IP address or tell it the IP address of the radio service, enter the secret, and finally check the box at hotspot so that your router knows it should use this radius for hotspot authentication. So by now you already have a layer 2 connection from your site to the data center. You have the hotspot asking user manager who is going to store all the accounts. So basically the complete service is up and running already. If you're offering something bigger, you will most likely have to adapt HTML and the account creation process. Luckily, we do not have to use the internal HTML pages of the hotspot. We can do so, you can adapt them, that is change them. You have a simple scripting facility there, but usually you will need more. You will want to integrate in a content management system. You want to have real scripting features or CSS or all the fancy HTML stuff today. So what you can do is you can tell hotspot to forward the login attempt to an external web server, and the external web server can use all standard HTML features to give you a fancy login page, and finally return username and password back to the hotspot, who is checking them with user manager, and finally forwarding to an external web server again, who is giving you success or failure, whatever it is. So it's very easy to have all web design capabilities without doing that on your hotspot router directly. That's not that complicated and is done frequently. And something else that many customers are not happy with it when they get their system out of the box is the way to pass the accounts to their users. If you're selling them online by PayPal or something like that, that's one thing, but usually Wi-Fi today is free, so you need to have some possibility to give account details to your user for free. You could do so at the hotel reception, but this is some extra work all the time, so most providers are actually offering an online registration, and many of them want to do SMS authentication. That's pretty popular for two reasons that we are going to look into in a second. And it's very good to understand that we have the API, the application programming interface of Router OS, to control or change the complete process when it doesn't fit our picture. So what you can do is forward the login to an external web server, and that external web server is also offering a mask for account creation. And once that account was created, you're using the API on that system to dynamically create an account in User Manager. So nobody's really touching User Manager, it's just done script-based. After that, you can, for example, have user details be sent by SMS from your web server, which is just simple scripting by today. So your user will receive username and password not on the web page, but on his mobile phone. And this is very useful for two different installations that we've seen. First one is you just want to allow your user to use 1 free hour per day, for example, and you limit that to 1 free hour per day per mobile phone number. So that's why you will need a mobile phone number. And the other reason is for legal security. Again, in Germany, this is still a pretty big topic. We are not very advanced with that. So it's a big headache for hotspot operators. They need to know who is using their service as good as they can. And if they know this person has access to this mobile phone number, this is a bit more of security than just having them fill out some forms in the web. So by now, we have the complete service running. We have user manager. We customized HTML. We are using the API to send SMS and create user manager accounts dynamically. That is, the public service itself is running in a way that, as I said before, quite a few companies are using and selling this as a commercial cloud service to hotels and all the other potential customers. As I told you in the introduction, dual use of the Wi-Fi infrastructure is getting a bigger topic. So what we cannot do so far is we can't offer the stuff of our customer a secure access to the local network based on the same Wi-Fi infrastructure. And that's what we are looking into now. MikroTik will give you the ability to build a virtual access point on top of the physical access point. That's what you see here. You see a physical interface and you see a virtual access point with two different SSIDs. And what we do next is we force traffic of both access points into different VLANs. If you do so, we can take care by a switch that all the traffic on the guest Wi-Fi is being passed to the tunnel router and to the data center. And all the traffic of the staff VLAN is forwarded to the local network. That's what you can see here. We have two VLANs created underneath the Ether1, which is here. And over here, we take care for the traffic being sent to the right bridge. That is, that traffic from the SSID or the virtual access point with the SSID stuff is being pushed to VLAN 2. And so we can make sure it's going all the right way from the access point to the VLAN switch into the local network. So by this little feature, bridging VLAN and virtual access points, you can offer dual use of the infrastructure to your customer and make sure only those people who know the encryption key will be able to use the local network. For big installations, this will probably not be sufficient, as you might have 200 people in the stuff all using the same encryption key. So you can take another step and you can go ahead and use personal encryption keys bound on special MAC addresses. So only those devices with the right MAC address and the right encryption key will be able to use your Wi-Fi. That's pretty nice, as your customer will only have to disable one account and not all of the staff have to change their encryption key. And it's another possibility to use user manager. You can provide your customer with an internal user manager down here, which is not being used for the public Wi-Fi accounts, but only for the internal staff accounts. So what happens when your mobile device, for example, is connecting to the SSID stuff? It's going to send its MAC address automatically to the access point, as well as using a special encryption key. And the access point is going to check that MAC address with radius. That is, it's going to look for a user belonging to this MAC address and receives back the encryption key. So if the MAC address and the encryption key are correct, the user is able to use the internal network. To do so, you have to extend the wireless security profile of your access point. Over here you see you have to add MAC authentication, and you also have to configure the radio server on that access point and check the wireless checkbox so the access point knows it should also check with radios for the encryption key. But here you did build a very fancy service. You didn't pay much. All the features are for free. You did quite a bit of configuration, obviously. But this is a service that you can reuse with all of your customers. Everything is set up centrally in the data center. You have customized HTML and customized account creation processes. And you also have dual use, that is your staff users can use the internal network without need of any additional software on their devices by a pretty good security. Oh, that's what I forgot. Sorry, that's the user manager end. So on the user manager, you will create an account using the MAC address as a username, and you're setting up the pre-shared key over here. So that gives you the infrastructure of user or MAC-based authentication keys. So now we want to have a look and build the same service using CapsMan and understand where CapsMan is giving us advantages. First of all, a short general theory to CapsMan. The naming is Controlled Access Point System Manager. That's the, let's say, Wi-Fi controller. And we have our caps down here. These are the access points. And the caps manager is providing different services for the access points. First of all, it's doing the Wi-Fi provisioning, so it sends the access point all the configuration. It can do its router OS updates, so you can force the access point to be updated if it connects to CapsMan. It can run ACLs, and it can take care or will take care of the complete client authentication. As I said in the beginning, there are two forwarding modes. Either the access points, the caps, are forwarding their traffic to CapsMan. That's manager forwarding mode. That'll be the standard that you're using. But you can also use local forwarding mode, and you will need that to build, for example, the Wi-Fi infrastructure for this stuff. There are three possibilities how the caps will connect to their CapsMan. There's a layer 2 discovery. That is, if you enable the discover interface in the access point in the cap, it will check the layer 2 network if it's going to find a caps manager, and if it does so, it can use it straight away. So that way you're not going to need any IP configuration on your access point. It doesn't need an IP, it'll do all it needs by checking for CapsMan. The second possibility, and that's, I think, very handy, and that's what we're going to use for the public Wi-Fi service, is to use a DHCP option. You can have your DHCP server also pass the CapsMan IP address to the caps. So that way, all you have to do on the caps is to enable the DHCP client. It will receive an IP address and also receive the IP address of the caps manager. That does not have to be in the layer 2 network anymore. It can be layer 3, so it can be in the data center. Third possibility would be to give a static IP address of the CapsMan to the caps. It's least flexible, but probably there are also some situations where you want to do that. So if you want to rebuild the complete service that we've seen before based on CapsMan, we have two advantages. We have fast and easy setup of the complete infrastructure, and we have an automatic provisioning of the access points. What we have to do is to install CapsMan on the hotspot device, or we don't have to install it there, but it will be most convenient in the data center. We'll install user manager and finally configure CapsMan, hotspot, and user manager. After that, you'll install the access points, set up the DHCP client on the access point, and have your local DHCP server send the CapsMan IP address. For CapsMan, there are two different versions right now. There's version 1 and version 2. They are not backwards compatible, so you have to decide which one you're going to use. If you're going with version 2, what we're doing right here in the example, you have to install the wireless CM2 package, which is an extra package that you download from MikroTik.com. And after you installed it, all you have to do, or the minimum setup, will be to enable capsman on the hotspot device. On site, you have to do two steps. You have to configure your DHCP server so to pass the capsman IP addresses. That's what you see here. It's just an option by now in the configuration dialog of your DHCP network. So you can enter one or more capsman addresses here. And on your access point, you will also have to install the capsman 2 package and check that button here in the wireless tables. Enable capsman, choose which interfaces should be dynamically configured by capsman, and that's all it takes on the access point. So that's what we got by now. With our local caps, which receive their IP address and their capsman IP address by DHCP, which will automatically get their configuration, which we're doing in the next step from the capsman, and which are automatically tunneling their traffic, as we see later on, to the capsman. We don't have to build any tunnels ourselves. All of this has been done by the cap and the capsman. Of course, you can add more sites to that structure too, so it's the same flexibility that you had in the remote setup that we saw without capsman. Actually, we're just missing the provisioning itself, so how is your Wi-Fi going to be configured? And this is the provisioning theory to Caps Manager. You build up multiple provisioning sets, and each provisioning set will contain one or more configuration links, and it will contain rules that need to match for this provisioning set to be in place. So what happens is that you go from the first to the last provisioning set for each interface which is being managed, and the first provisioning set that matches is going to be used. So in our example here, the first one has a matching rule. A rule could be, for example, a MAC address, or technical aspects like only 5 gigahertz access points or only 2.4 gigahertz access points. So let's say that one is matching, and once we found out it's matching, we look at its master config. The master config is a link to a given configuration, what you see down here. And if we found that master configuration, the first interface is going to be configured. The physical interface of the access point is going to use the master configuration in the provisioning set that has a matching rule. After that, we check for slave configuration, and a slave configuration will result in a virtual access point. The master configuration is the physical access point or the physical interface, and the slave configuration is a virtual access point. So what happens now is we found another configuration, and we will set up a virtual access point here. That can continue for more steps. In this example, I did choose 2 slave configurations, and so a second virtual access point is going to pop up. Now let's have a look at a real example. What we want to do is one SSID called guest Wi-Fi for all interfaces, then an extra SSID for all 2.4 interfaces, which you will see here, and an extra SSID for the 5 gigahertz interfaces. This will allow your customers to choose if they want to make sure they're using the 5 gigahertz access points, for example. Down here you can see all the dynamic interfaces which are being created on the Caps Manager, 2 master interfaces and 2 slave interfaces. And here this is the resulting Wi-Fi structure, 2 Wi-Fis with guest Wi-Fi as an SSID, 1 with 5 gigahertz and 1 2.4. Please take care, this is not how it's really going to look. This is just an example on a real Caps managed access points. All the interfaces will be disabled, and you'll see a real screenshot later. To do that, you create 2 provisioning sets, 1 for hardware modes that support B standard, and 1 for hardware modes that support A standard. You'll give them the same master configuration, but different slave configurations. In the configuration itself, you only have different SSIDs. You will make sure that the data path, that is the way the traffic is forwarded on the Capsman, is set to the bridge that is connected to the hotspot. and you don't need any security. And this is going to be your result. This is the real screenshot from a CAP, from an access point. You see all the interfaces are disabled. You see only some red lines that inform you that this device is remotely managed. And here you can see 1, 2 physical interfaces and 1, 2 virtual interfaces beneath. If you go into the details, you will not be able to do any changes. Actually, the only setting from the local access point that is being looked at by CAPS Manager is the antenna gain. So that's actually something that you can set on your local device before you enable CAP, and it's going to be looked at since antenna gain might be different on different access points. So far you did rebuild the complete infrastructure that we've seen before. You have central CAPS Manager. You don't have to care for the tunnels. These are built automatically from your customer side to the data center. You have different SSIDs. You don't have to take care of the deployment of the access points. All that you have to do is enable CAPS there, tell them to use the HCP client, and tell them that both of their interfaces are going to be managed by CAPS. And maybe you want to set a password, obviously. So there's one thing left to discuss. That's the last thing. That is a virtual interface for our stuff also possible? We've seen that we can do multiple virtual access points by using multiple slave configurations, but the local traffic for the local stuff, or the traffic for the local stuff, should be forwarded locally. And there's one problem in that. That is, the virtual interfaces are not going, or the traffic flow for the virtual interfaces on the access points are not going to be controlled by your CAPS Manager. So you have to control it locally. As these interfaces are dynamically configured, they will just pop up during the provisioning process, so you cannot add them to a given bridge when you roll out your system. So what you have to do is you add a third or a second slave configuration over here, and that slave configuration is a little bit different. You will do security configuration to have an encryption key, and in the data forwarding or the data path configuration, you will add the local forwarding. You don't forward to the central CAPS anymore. And on your access point, and that's important to understand, you also have to do one change. You have to add the local bridge here. You have to tell that access point traffic on the stuff interface is going to be forwarded locally. It should be, the interface should be pushed to this bridge here dynamically. And you see these interfaces in local forwarding that are not going to be disabled. They're enabled, and so you can handle their traffic flow on the access point locally. That's basically it. I think I probably did overshoot in time anyway. So thanks for listening. Enjoy your lunch. If you have any questions, I'll be around in the exhibition area. And yes, thanks for listening and have a good month.